Could anyone possibly ignore the latest news about Object 3 Atlas today? For several months now, this story has been exciting the scientific community, journalists, and just space enthusiasts alike. Everyone is asking the same thing. What is this object? Where did it come from? And why is it behaving so strangely? Ever since this mysterious object was first detected by telescopes, debates about it have not ceased. Some believe it's just a comet, an interstellar wanderer that came to us from the distant depths of the galaxy. Others think it's an artificial probe created by an alien civilization. And somewhere between these versions lies the truth, which humanity has yet to uncover. Of course, we are all romantics at heart. After all, you must agree, how wonderful it is to think that somewhere out there, light years away, someone built a ship that one day crossed the interstellar abyss and ended up near the sun. But even if that's not the case, even if it's just an icy fragment from a distant planet, isn't that a miracle in itself? The story of 3 Atlas began in one of the driest and most desolate places on Earth, the Atacama Desert, where automated telescopes of the Atlas program, Asteroid Terrestrial Impact Last Alert System, stand on mountain peaks. This is a special network of optical eyes, surveying the sky around the clock. Their task is to detect in time any moving objects capable of crossing Earth's orbit. And so, in early 2024, one of these telescopes spotted a faint point of light moving slightly differently than ordinary asteroids or comets. After calculating its trajectory, scientists quickly realized it does not belong to the solar system. The object is flying in from the outside, from the depths of the galaxy. Thus, the third representative of a new class of bodies, interstellar visitors, was born. The first was the famous 1I Oumuamua, discovered in 2017, followed by 2I Borisov in 2019, and now 3I Atlas, the third in line, but perhaps the most mysterious. Its name is not arbitrary. The number 3 is its serial number. The letter I comes from the word interstellar. And Atlas is the acronym of the telescope that discovered it. Thus, 3I Atlas literally means the third interstellar object found by the Atlas observation system. Simple and logical. But behind this simplicity lies a real revolution in astronomy. Just 10 years ago, no one could have imagined that interstellar bodies could be seen with a telescope. Now, astronomers are sure there are many more such objects. It's just that earlier technology didn't allow us to notice them. Because the behavior of 3 Atlas turned out to be far too strange. Its orbit is unusual. It entered the solar system almost in the plane of the ecliptic, meaning almost parallel to the orbits of the planets. This is an extremely rare coincidence. American astrophysicist Avi Loeb, known for his bold hypotheses, immediately stated, "This is not a coincidence. Perhaps we are observing not a natural object, but something created by intelligence." His argument is simple. The odds of entering the plane of the planet's orbits are so small that it resembles a well-aimed shot at a moving target. Loeb said, "It's as if it took aim while flying towards us." Sounds intriguing, doesn't it? Allow me to draw a simple analogy. Recently, my friends and I decided to play darts. We hung up the target, took the darts, and, as often happens, we just couldn't hit the bullseye, always on the edges. And suddenly, an elderly woman was walking by. She stopped, looked, and asked, "What are you guys doing?" "Oh, we're just throwing darts. We want to hit the bullseye, but it's not working." She smiled. "Let me try." She took a dart without even aiming, threw it, and hit the bullseye perfectly. We were amazed. "Come on, do it again," we asked. She was surprised. "What, did I really hit it?" And threw another one. The second and third times, misses. Well, sometimes chance can be strikingly accurate. And statistics, as a science, teaches us we can only judge probability based on a large sample of events. One hit on the bullseye proves nothing. It simply falls outside the statistical norm. The same is true with interstellar objects. If 3 Atlas were the only wanderer to enter the solar system at such an angle, we couldn't draw a conclusion about a pattern. But this is already the third visitor in 8 years, and each of them flew on its own unique trajectory. Oumuamua flew almost perpendicular to the orbital plane. Borisov at an acute angle, and Atlas almost along the ecliptic itself. Perhaps this is not a coincidence, but simply a result of the fact that we now have powerful observation tools. After all, the better the telescopes, the more we see, and the more often we notice what was previously hidden. Today, astronomy is experiencing a true observational renaissance. Previously, scientists only detected comets when they were already shining in the sky with their tails. Now, automated systems scan the sky every night, processing millions of images. Computer algorithms find moving points, compare them with databases, calculate orbits, and all within a matter of hours. Therefore, new interstellar visitors, which once flew by unnoticed, will now be detected regularly. 3 Atlas became not just another point in the sky, it became a symbol of a new era when humanity has learned to see even those travelers that come from afar, from beyond our home star. When the object approached the sun, the strangeness began. At first, astronomers thought it was an ordinary comet. It was evaporating, releasing gas and dust, forming a tail as it should. But on further observation, it turned out that the tail was pointing not away from the sun, but towards it. This phenomenon was called an anti-tail, and discussions immediately flared up. How is this possible? After all, the solar wind should blow dust and gases in the opposite direction. Some scientists even joked, maybe it's not a tail but an engine nozzle. Of course, it's a joke, but every joke has a grain of truth. After all, we had never seen comets whose tails pointed against the solar wind. To understand, we need to recall the physics of comets. The head of a comet is the nucleus, a dense body of ice and rocky inclusions. Under the influence of solar heat, the ice begins to evaporate, ejecting gas and dust. These particles are blown away by the stream of light and plasma, the solar wind, and form the tail. Usually, it trails behind the comet, in the direction opposite the sun, but sometimes we see a strange illusion. The tail appears to point the other way. This is an optical effect that occurs when a comet is moving directly towards us. The curve of the real tail in space, in projection, looks like it is facing the sun. This is possibly how the anti-tail of 3 Atlas appeared. However, things are not that simple here.
When 3 Atlas was just approaching the inner planets, astronomers were watching it closely. At first, the comet's behavior was quite standard. Slight evaporation, a faint coma. Nothing suggested a sensation. But soon, the images showed something strange, a tail pointing towards the sun. This behavior was difficult to anticipate. After all, everyone knows the solar wind drives gas and dust away, pushing them behind the comet. And then suddenly, an anti-tail. It looked like a narrow beam stretching towards the sunlight. Naturally, debates began. Some spoke of a rare optical effect, suggesting the comet was heading towards Earth, and the real tail just appeared to point forward due to perspective. Others insisted, no, it's something else here. The physics of the process is different. To understand how this is possible, it's worth recalling what comets are like in general. Every comet is like a time capsule. It was born billions of years ago when a star system was forming. Far from its star, the material remained cold, not evaporating, and gradually gathered into clumps of ice, frozen gas, and dust. When such a body is ejected from its system by gravitational interactions, for example, during a close encounter with giant planets, it can become a free wanderer and drift for millions of years in the interstellar void. In the abyss of space, the temperature is near absolute zero. Everything that can freeze does. Water turns into ice, carbon dioxide into dry ice, methane and ammonia also become solid. This is how the nucleus forms, dense, fragile, but stable. And then, after millions of years, when it approaches a new star, the miracle of awakening begins. As it approaches the star, the comet's nucleus heats up. Carbon dioxide evaporates first because its sublimation temperature is lower than that of water ice. Then water, ammonia, methane begin to evaporate. It all depends on the distance to the sun.
gas bursts out, carrying with it tiny dust grains and ice crumbs. They form a glowing coma, a gas dust envelope, and a tail streams behind it. For 3 Atlas, this process began unusually early, still beyond the orbit of Mars. This alerted scientists. It means the material was evaporating at a very low temperature. Such an effect is possible if the composition is dominated by dry ice, not water ice. Further observations helped reconstruct the picture. The comet rotates rather slowly, about 1 rotation every 16 hours. This means the same side of the nucleus is exposed to solar heating for a long time. On this sunlit side, the CO2 ice began actively evaporating, ejecting jets of gas directly towards the sun. The flow was so stable that it created the illusion of a forward-pointing beam. But this gas flow also contained small pieces of water ice which gradually heated up and evaporated further away from the comet. It was they that produced the characteristic glow perceived as the anti-tail. So everything is explained simply. The nucleus was dominated by dry ice, the comet rotated slowly, solar heat acted on one side for a long time, and streams of gas and dust went towards the sun, not backwards. No mysticism, pure physics. Nevertheless, scientists were hooked precisely by the uniqueness of this combination of factors. After all, anti-tails in comets do occur, but extremely rarely, and they are usually observed together with a normal tail. In the case of 3 Atlas, however, initially there was only an anti-tail, and it looked as if the comet was piercing the sunlight. In the images, it was narrow, dense, with clear boundaries, like a directed spotlight. And then, when the object passed perihelion, the closest point to the sun, a normal tail did appear. But by that time, interest in the comet had already become enormous. For the first time ever in observations, we saw an interstellar body demonstrating a reverse tail even before significant heating. To understand the scale of the strangeness, let's recall that the solar wind is not a metaphor. It is a real stream of charged particles coming from the sun in all directions. Its speed is about 400 kilometers per second, and sometimes during flares, it exceeds 800 kilometers per second. These particles, mainly protons and electrons, carry a magnetic field with them. When they encounter the ionized gas of a comet, they hook it, bending the tail. That's why for most comets, the tail always points directly away from the sun. 3 Atlas, at some point, seemed to be moving against the wind. This was the very scientific challenge that forced a revision of old evaporation models.
Not only ground-based observatories came to the rescue, but also space telescopes. Spacecraft observing in the infrared range detected increased CO2 emission and traces of methane. Spectra showed, indeed, this comet has a record amount of frozen carbon dioxide. Analysis of its brightness confirmed that its surface is uneven, possibly covered with a crust of dust and frozen gases, with more volatile layers hidden beneath the surface. It was from these that the jets erupted upon heating. Some frames even allowed estimates of the ejection speeds, about 100 meters per second. This is not much, but enough for the gas jets to form local streams visible through a telescope. To appreciate how unusual 3 Atlas is, it's useful to compare it with the 2 previous interstellar visitors. Oumuamua 12017 was a rocky or metallic body with no visible tail. Its trajectory and rotation are still debated. It accelerated when moving away from the sun, as if something pushed it. This spawned many hypotheses, from hydrogen evaporation to an artificial origin. Borisov 2019, on the contrary, was a classic comet. Dust, gas, tail, everything as it should be. It resembled familiar objects from the Oort cloud, only it came from another system.
But 3 Atlas turned out to be something in between them, outwardly a comet, but with uncharacteristic behavior, an unstable tail, and a strange chemical composition. This object seems to combine the features of the 2 previous ones, as if continuing an invisible evolution of interstellar wanderers. For scientists, 3 Atlas was a real gift. It confirmed that interstellar comets are not something exceptional. Rather, they represent a natural byproduct of planetary system formation. When a young star is surrounded by a protoplanetary disk, collisions, ejections, and gravitational slingshots constantly occur within it. Millions of bodies lose stable orbits and fly off into space. Some of them, after billions of years, may cross the orbit of another star, like our 3 Atlas. In fact, each such comet carries samples from alien worlds. Their composition tells us which elements and compounds are present in other stellar systems. And in this sense, by observing them, we are like peeking into the laboratory of distant planets. Detailed spectral analysis revealed interesting things. The coma contains carbon dioxide, CO2, the main volatile component, traces of water, H2O, methane, CH4, ammonia, NH3, and small impurities of cyanide compounds, typical for comets. But the ratio of these substances is unusual. The proportion of CO2 turned out to be several times higher than in most comets of the solar system. This confirms that 3 Atlas was born in a much colder environment, possibly in the outer regions of some star system where the temperature is even lower than in the Kuiper belt. Such conditions allow the formation of dry comets, which have little water but plenty of carbon dioxide and methane. Judging by the brightness fluctuations, the nucleus rotates slowly and unevenly. Its shape is probably elongated, like a nut or a potato, and the rotation axis is tilted relative to the direction of flight. This creates an effect where one side is illuminated for a long time while the other remains in shadow. This slow rotation not only explains the stable anti-tail, but could also affect the trajectory. After all, reactive gas ejections act like mini engines, gradually changing the direction of flight. Therefore, even the slight acceleration detected by telescopes became another confirmation. The nucleus is actively evaporating and perhaps even gradually disintegrating. Some calculations show that 3 Atlas, after passing perihelion, began losing mass at a tremendous rate, up to several tons per second. This means its nucleus has likely already cracked and broken apart into many small fragments. If so, then at present we are not looking at a single solid object, but a whole cloud of particles moving along a similar trajectory. This behavior resembles the fate of Comet Atlas, C219Y4, which also disintegrated upon approaching the Sun, losing more than half of its mass.
When Comet 3I ATLS disappeared from view, only traces remained. Light curves, spectra, images, and most importantly, questions. It came from nowhere, shone with a strange light, and vanished again into the silence of space, leaving scientists with only the possibility to guess what truly happened. And yet, even this brief encounter changed much. After Oumuamua and Borisov, it was 3I ATLS that finally cemented the idea: visitors from other star systems are not rare. Astronomers are now convinced that the space between stars is literally littered with such bodies. It's just that most of them are too faint to be noticed. And this realization is staggering. Each of these tiny comets is a messenger from another star. They carry within them the chemical imprint of an alien world, of their home sun, and perhaps even particles of the substance from which alien planets and oceans could have once formed. Imagine, the ice we saw on Comet 3I ATLS was once part of a distant system, possibly orbiting near an exoplanet where methane rain falls. And now, this ice has evaporated in the rays of our sun,
and we were able to measure its spectrum. This is not just observation. It is a meeting of worlds. Many scientists have begun to say that interstellar objects are a kind of cosmic debris, fragments ejected during the birth of planets. And there is nothing poetic about that. But if you think deeper, wasn't our Earth also born from such debris? Every dust particle, every fragment of frozen gas could once have been a building block of a new world. And perhaps among the countless bodies flying through the interstellar abyss, there are those that carry traces of organics, simple molecules capable of becoming the seeds of life. Comet 3I ATLS, with its abundance of carbon dioxide, methane, and ammonia, could have been just that. These compounds are the basis of the chemistry that, under the right conditions, gives rise to amino acids and ultimately life. So the question is not what was it, but where it came from. Trajectory modeling showed that Comet 3I ATLS came from an area of the sky near the constellation Lyra, roughly from the same direction as Oumuamua. This coincidence is difficult to call random. Perhaps both comets originate from the same stellar association, a group of young stars ejecting billions of bodies into space. If this is true, then we are effectively seeing not individual wanderers, but an entire generation of interstellar objects moving along similar trajectories. In other words, the solar system lies in the path of a galactic stream of such bodies. This idea opens up new perspectives. If streams exist, then it's possible to predict the appearance of the next interstellar comets in advance and prepare to meet them. Today, NASA and ESA are already developing projects for probes capable of catching up and studying such objects. One of the most ambitious is the Comet Interceptor mission, whose launch is planned in the late 2020s. The spacecraft will wait in orbit, and as soon as astronomers detect a new interstellar object, will rush towards it. The goal is simple: to meet the guest face to face, take pictures of its nucleus, collect dust samples, and measure its chemical composition on the spot. If we manage to catch an object like 3I ATLS, humanity will for the first time be able to touch, even if remotely, material from another star system. Sometimes, it seems that discoveries of this kind have no practical use. So what? Just another comet, another strange object. But if you think about it, isn't it precisely from studying such trifles that the greatest ideas grow? Once, observing comets helped us understand gravity. Once, a meteorite fall convinced scientists that Earth is not isolated but constantly exchanges matter with space. And today, interstellar comets suggest we are part of a much larger galactic ecosystem where material circulates between stars. Perhaps this is how life, in the form of organic molecules frozen in comets, travels across the galaxy, crossing light years to one day be born again. When you look at the images of 3I Atlas, it's hard to shake the feeling that this is not just a rock with a tail, but a herald of something greater. It flew past us, lonely, ancient, incomprehensibly distant, and disappeared, like a spark in the night. But that spark ignited a new understanding. Our solar system is not unique. There are billions of such systems, and each one of them ejects its own wanderers into space at some point. They carry the memory of their stars, and, colliding with us, they seem to say, "You are not alone." What if it was such interstellar objects that brought the first organic molecules to Earth? What if life is not a miracle that happened once, but a pattern repeating everywhere there is warmth, light, and water? Perhaps a comet, like 3I, Atlas, once fell onto the primordial Earth or onto another planet in another system, and brought with it those very compounds that one day assembled into the first cell. And then everything around us is the result of an ancient exchange between stars. Every atom in our body, every molecule of water, every breath is a trace of matter's long journey through the galaxy. Today, astronomy is experiencing a renaissance. Technologies that just yesterday seemed impossible are becoming reality. Telescopes see farther. Detectors sense the faintest flashes. Artificial intelligence finds objects that a human might have missed. It is quite possible that within a few years we will discover dozens, maybe even 100, of interstellar bodies. And among them, there will certainly be those that become new mysteries, no less amazing than 3I Atlas. And so ended the story of one strange comet. We don't know where it is now. Perhaps it has already crumbled to dust. Perhaps it continues its journey, slowly receding towards other stars. But for a moment, it crossed our celestial stage, and that moment was enough to remind us the cosmos is alive, dynamic, and full of wonders. 3I Atlas is not just an object in an orbit. It is a symbol of movement, chance, the eternal exchange between stars. It is proof that even in the cold void, stories are born, and each one of them can change our understanding of the universe. And perhaps someday, far in the future, another civilization observing our solar system will notice a tiny speck of dust flying near their star, and they will say, "Look, a comet from another system. It came from where there is a sun."